Now let us discuss those circuits in which resistor and capacitor, both of them are included. That is popularly called RC circuit. R stands for resistor and C stands for capacitor. Remember that to discuss these circuits, the charging process of a capacitor. Remember the charging process of a capacitor. If you join a capacitor to a voltage source through a resistor, then in the beginning some charge will be flowing coming to the capacitor. After some time the capacitor will be charged completely and the current will stop flowing in this resistance. So we say that the constant current for solving RC circuits, remember that constant current or steady current, constant current or steady current does not flow through capacitor. Does not flow through capacitor. Remember that a constant current does not flow through a capacitor. With this much idea, you will be solving any of the RC circuits. Let us take an example. Understand a situation in which a resistance R1 is here, a resistance R2 is connected in series with a capacitor C, and a voltage source V along with another resistor R3 is connected this way. Understand, this is a kind of situation in which three resistors R1, R2, R3 are given. They are connected to a voltage source. In series with R2 there is a capacitor C, and you have to find energy stored. Find energy stored in the capacitor C. Let us suppose the question is that what is the energy stored in capacitor C? Now whenever you see this kind of question, then the first thing you have to understand that the current in the beginning might have flown through this branch just to charge this capacitor, but once the capacitor is completely charged, जब ये कैपेसिटर पूरी तरीके से चार्ज हो जाएगा, then no current will be flowing in this branch. जैसा कि आपने प्रीरिक्विजिट में लिखा था that a constant current does not flow through capacitor, but that does not mean that charge is not appearing on capacitor. इसका मतलब ये नहीं कि कैपेसिटर पे चार्ज नहीं है, rather कैपेसिटर पे पूरा चार्ज है. Since the capacitor is completely charged, that is why constant current is not flowing in this branch. You understand? So in case the constant current is not flowing in this branch, then the potential drop across this R2 will be 0. जब इस ब्रांच में कोई करंट फ्लो ही नहीं कर रहा तो R2 के क्रॉस पोटेंशियल ड्रॉप 0 हो जाएगा, बिकॉज पोटेंशियल इज I into R. तो इन केस इसके क्रॉस पोटेंशियल ड्रॉप 0 है तो आप अपने एक सर्किट में इस R2 को रिमूव करके दोबारा ड्रॉ करेंगे. You will draw an equivalent circuit of this in which R2 will be removed. Why R2? Because this is connected to capacitor and no constant current passes through capacitor. That means the equivalent circuit of the given circuit will become something like this. The equivalent circuit will be something like this. ये ऐसा हो जाएगा. Now see what is the question. Question is energy stored in capacitor. अगर आपको इसमें एनर्जी स्टोर्ड निकालना है, then you should know what is the potential drop across this capacitor, because energy stored के लिए you can successfully use the formula half CV square. You understand? आपको इस सर्किट में कैपेसिटर के क्रॉस पोटेंशियल ड्रॉप निकालने के लिए you should know what is the current flowing into the circuit. Now you know that the steady current is not flowing here, so the current must have been flowing in the outer circuit itself. So current, let us suppose I is flowing here, then the same current I will be flowing here, isn't it? Can you calculate the value of current I? Of course, yes. This current I will be the supply voltage V, and you should understand that this R3 as well as this R1, they are in series, because same current is passing through both of them. So in case both of them are in series, then total resistance is R1 plus R3. This is the current flowing in the outer network as it has been shown here. Now next work is to find out the potential drop across capacitor. Then you can understand that this C and this resistor, they are in parallel. यहाँ पे अगर आपको कैपेसिटर के क्रॉस पोटेंशियल ड्रॉप निकालना है तो आप इस रेजिस्टर के क्रॉस पोटेंशियल ड्रॉप निकाल लीजिए, बिकॉज दोनों पैरेलल में कनेक्टेड हैं, और पैरेलल में जब चीजें कनेक्टेड होती हैं तो दोनों के क्रॉस पोटेंशियल सेम होता है. हियर सिंस कैपेसिटर एंड दिस रेजिस्टर दे आर कनेक्टेड इन पैरेलल, सो बोथ ऑफ देम will be experiencing same potential drop. So I am writing potential drop across C. Potential drop across C is equal to I into R1. Why I into R1? Because these two are connected in parallel, and I into R1 is the potential drop across this resistor. If you substitute the value of this I, then this is V upon R1 plus R3 multiplied by R1. This will be the potential drop across the capacitor. Now whatever you feel like you can calculate. In case the question had demanded what is the charge stored in the capacitor, then you should have multiplied this C value with this V R1 and so on. In case they have demanded what is the energy stored in this capacitor, then simply you use the equation half CV square. So you can say energy stored is equal to half C and this much potential drop, that is V R1 upon R1 plus R3 whole squared. So this is the final answer you will be having for this question. Now let us discuss an advanced example on RC circuit combined with Kirchhoff's law and so on. Take an advanced numerical on RC circuits. Imagine a situation in which a branch of the network is given to you. Here you have a capacitance, say of 10 microfarad, this side 1 ampere is approaching, from this side 1 ampere is approaching. This is 2 ohm, let us suppose this is 1 ohm, this side is 1 ohm, this side is 2 ohm, let's suppose this is 3 ohm, 2 ohm, 1 ohm. Imagine 7 ampere is going this way, 1 ampere is written this way. This is the situation which has been given to you. In this entire network, you see, in some of the branches currents have been given, in some of the branches currents have not been given. All the resistors have been mentioned, and in between here you have a capacitor connected. Capacitor value is 10 microfarad, and you have to find out the energy stored. You have to find out the energy stored in the capacitor. You have to find out what is the energy stored in the capacitor. Now remember that the first thing which you will have to do in this entire network is to find out the potential drop across this capacitor, as we did in the last example. And to know the potential drop, you should know the currents as well as the value of resistor in adjacent branches. You see, the value of resistance is given. सारी जगह हमने resistors की value दे दी है. Now your next step will be to find out what is the current flowing into them. In case you will know what is the current in them, then only you will be able to find out the potential drop across this capacitor. It is clear to you that steady current will not flow in capacitor. ये आपने पहले भी देखा है कि कैपेसिटर के थ्रू स्टेडी करंट नहीं फ्लो करता. Here you can apply Kirchhoff's first law, junction law, to find out first the current in different branches. जैसे आप यहां देखिए 1 ampere current is approaching and here 1 ampere is approaching. Now on this junction the total 2 ampere is approaching, so you should understand that 2 ampere must have flown in this 1 ohm resistance. You understand? 2 ohm must have flown here, क्योंकि 1 and 1 2 ampere अगर आ रहा है तो यही 2 ampere जाएगा. इस कैपेसिटर में तो कोई करंट फ्लो ही नहीं कर रहा, बिकॉज स्टेडी करंट वहां नहीं फ्लो करता. सो 2 ampere is going this way. Now the same 2 ampere current will be flowing in this 2 ohm resistance, क्योंकि यहां पे तो और कोई ब्रांच है ही नहीं. Helplessly this 2 ampere current, this will be passing into this as well. Now if you concentrate on this junction, अगर आप गौर से इस जंक्शन को देखिए, then here 2 ampere is approaching, यहां से 2 ampere आ रहा है, but 7 ampere is going away, isn't it? 2 ampere आ रहा है and 7 ampere यहां से चला गया है. That means from this side 5 ampere must have come in this direction. जब 5 ampere यहां से आएगा, then only it will be adding to 2 ampere and that will satisfy the junction law. तो हमारा 5 ampere current यहां से अप्रोच करना चाहिए. Rest what current is flowing here, that can also be calculated, but we do not require that. Why? Because our aim is to find out the potential drop across this capacitor. So only branches we want are these three. Once you will start moving in these 3 branches, then whatever potential drop you will experience, that will suffice your purpose of calculating the potential drop across this capacitor. Now suitably apply plus minus sign. Assume that the point this is A and point this is B. If you apply plus minus sign, then in the direction of current flow, this side will be plus, this side will be minus. Here also in the direction of current flow, this will be plus and this will be minus. And here also in the direction of current flow, this will be plus and this will be minus. You understand? Now you start moving from A. You are at point A. If you jump here, you will be losing potential. आपके potential का loss होगा, plus से minus आएंगे आप. Loss कितने का होगा? I into R. तो that is minus 2. यहाँ से यहाँ तक potential का loss हुआ 2. Then if you will be jumping here, plus 2 minus, again there will be a loss. This is minus 4. right? You have reached here, and if you will be jumping from this place to this place, आप माइनस से प्लस जाएंगे, you will be gaining, that will be plus 15. You understand? That will be plus 15, and finally you will be reaching point B. So this will be equal to B. Potential drop across capacitor देखा जाए तो VBA, VAB कुछ भी बोल सकते, say VBA, whatever it is, you take the positive value of this. This is, you can see here, 9 volt, isn't it? VBA, that is difference of these two. If you try to look at this, VBA is VB minus VA. VB minus VA. This can be written as 9 volt. You understand? इनका difference 9 volt आ रहा है. Take the positive value of that. And then energy stored in the capacitor. Use the formula half CV square. What does this V stand for? V stands for this potential difference you have taken here, VBA. You understand? So this is equal to half into C. C is 10 microfarad. It is given to you in the question, 10 microfarad. यहाँ दे रखा है आपको क्वेश्चन में कि C की वैल्यू 10 माइक्रोफैरड है, तो आपने वो सब्स्टिट्यूट कर दिया, हाफ इंटू 10 माइक्रोफैरड, एंड द वैल्यू ऑफ पोटेंशियल ड्रॉप V, दिस इज 9 वोल्ट, so this is 9 square. You understand? Now if you will solve this, then you will be getting 405 microjoule. So this is the final answer you will be getting for this network. यहाँ पे क्वेश्चन में आपको a part of network branch दी हुई थी, and you were expected to calculate the energy stored in the capacitor. So you saw that in this question आपने Kirchhoff's first and second law का भी use किया, and then you used RC circuits, and finally you got the answer. Now before I move ahead, let us summarize what all we discussed in the lecture today. In this lecture of networks, first we saw the series and parallel combination of resistors. You essentially used the formula R is equal to R1 plus R2 plus R3, or for parallel combination you derived the formula 1 by R is equal to 1 by R1 plus 1 by R2 plus 1 by R3. Then you discussed the Wheatstone bridge, balanced Wheatstone bridge, how to identify them. Then you discussed symmetrical networks. Then you discussed the master formula, that is as Kirchhoff's law or Kirchhoff's rule. Essentially there were two laws or two rules here. And finally we discussed RC circuits. We solved certain advanced numericals also, which involved the concepts of Kirchhoff's rules as well as RC circuits. Now that is all in today's lecture. In the next lecture we will be dealing with various combinations of cells. Thank you.